Hi everyone, good morning. Hope everyone is enjoying the conference so far. Welcome to this 5th plenary session, which is going to be on non-local consciousness and extrasensory perception. Our first talk today is kind of a follow-up on the workshop we did on this topic this past Monday. About 150 people of you were there already, so you know what it is all about, but the rest you missed it. And today we're not gonna repeat that session, but David is gonna come up on stage and tell us a bit more about what you saw, those who saw it last Sunday. We're also gonna have a little surprise for you. For those who came on Sunday already know about it. And then David will talk a bit more about how we're investigating in his lab this quite incredible phenomenon of extraocular vision. Okay, so we're going to start with David del Rosario, director of the INAP lab here in Barcelona. David.
Thank you, Tony. It's known that eyes are used to perceive the colors and shape of the world around us. The thinking eyes are necessary to perceive the visual world is well established in our mindset. Okay. To begin, Shiva and Guru will share a demonstration that serves as the foundation for the experimental work presented in this session.
So good morning, everyone. So just for a little bit of a context, we are representing the art of living and the intuition process. What is intuition? Maybe some words from the audience. Would you like to say? Gut instinct, fantastic. Anyone else?
Something non-rational.
Something not rational. Getting information from other dimensions. Anything else? Yes, please. Inner knowing. Fantastic. Looks like we have an evolved audience here. Integration of all senses. Fantastic. So we have 3 ways in which we consume knowledge. The first way is through our senses. We usually say what we see is what we believe, isn't it? But we see that the sun rises and sets. Is that true? So, intellectually we know that the sun is not rising and setting, but it's the earth going around the sun, isn't it? So the knowledge that we get from our intellect is superior than that of our senses, isn't it? And then there is another way where we get information, and that is through our intuition. Intuition is our inner guidance factor. So in the workshop that we teach in the art of living called the intuition process, we train children to access into these inner dimensions. And we are going to do a quick demo on what they are able to do once they access these dimensions. Would you like to see? So we invite Guru Prasad and Shiva. And shortly, we'll be calling upon a few members of the audience. Now remember, these are children, and we ask you to be please respectful of their space. So who would like to be first to volunteer? We would like to show you our blindfold. Maybe somebody can come and test it out for us. Anyone? Yeah, please. Do you see anything?
No.
Anyone else from the audience? Yes, please do. Yeah, you can use the tissue to wipe it and then just put it on. Yes, you can just do that. What do you see?
Nothing.
Okay, thank you. Perfect. All right, so now I would like to call a member of the audience to come with Shivapriya. You can step down. So who's our first volunteer? Yeah, please do. You're right at the back. So I would like you to draw a simple picture on this board, and Shiva will copy that. You can use any of the colors. Yeah, you can also use multiple colors. Yeah. Thank you. You're an artist. Shivapriya. I will hand you the colors. You can choose the ones. You may also say what you're drawing.
It's a Christmas tree, like with green and then small round circles.
Great. She just said that it's a Christmas tree with rounds on it, circles on it. Yeah, can you move aside? Yeah. Wonderful. Thank you, Shiva. If you can see, she drew it exact number of circles on both sides. Okay, I would like another volunteer from the audience. Oh, on the screen. Yeah. Yeah, please do come. And I would request you to write something on the page in any language. Yeah. You can write here. Here. A little bit lower because. Can you come forward and you can just pick. That's it? Yeah, thank you. So she wrote the first two words. Okay, so now can I have Guru Prasad here? So Guru, can you put on your blindfold? And we have a Rubik's Cube with us. Maybe an audience member can come and help us scramble this. Yeah. Fine. Come. Guru? Yeah. Wonderful, Guru. You can keep putting your blindfolds. Maybe Shiva, you can also put on. Yeah. So I would invite an audience member to give a reading material, maybe a visiting card or something, some information that they are not afraid of sharing in the public. Yeah, can give it to me. Yes. Can you confirm that she's not seen it before? No. Okay, Shiva can hold it, and you can read from the top.
Okay, so it's blue and has like green and orange, like an M sort of symbol, like a wavy something. And then in blue there's mind, and in green there's life with the I dot orange. Then in black, Mind Life UK Ltd, 5 Ravenscroft Avenue, London, NW110SA, +447676300, HTTPS, Doppelpunkt? Those, yeah, / mindlife.net, and then capital T, and then not capital UVE at mindlife.net.
Can you tell? Yeah.
Oh, there's another side? Oh,
On the left side.
oh here?
Yeah.
On top there's the Tuvi Orbach, German, with a picture of him. Yeah.
Very good. Can you confirm that?
Brilliant. She's really brilliant.
Yes.
I think this knowledge is important to bring to education now. It's missing in education. Teaching only math, and which is important, but this is an important aspect to teach.
Wonderful. Anyone else? Maybe you can we can quickly show this. Yes. Okay. Guru, can you describe what's on this card?
It's a picture. says Barcelona 2021. There's a picture of some person here with sort of snakes or animals on the head.
Wonderful. You want to say more?
No, there's actually nothing more.
Okay, now as the last thing, maybe Shiva, you can put on your blindfold and we will have you playing a game on her iPad. Yeah, you can start.
Shall I start?
Yeah, please start. All right, thank you so much, Shiva. Big clap for Shiva and Guru. So what we see here is just one aspect of what the kids can do. Many kids are able to do these wonderful blindfold activities with 100% accuracy, as you can see here. Many kids are able to predict what's going to happen next. Kids are able to find objects that are missing. They've even been able to help the police find missing people. So as you can see, this is something that can really revolutionize our education system. And I would really request the audience member, if you are interested in knowing more about this from us, we are available just after the session. We would like to connect with you personally. We would love to collaborate with you on research, and we would love to find more ways of bringing it out there to the education system. And we also have these courses in blind schools, for example. The kids are able to see without eyes. We are bringing these courses for autistic kids and differently able kids, so possibilities are endless. Thank you all for your attention.
Thank you. Well, after this amazing demonstration, why does the scientific community reject the possibility of the extraocular vision phenomenon? The argument one is inadequate blindfolded. Often, blindfolds are not fully light tight, especially around the nose or when the child is tilted their head. We identify a need to create a miniaturized and accurate system to measure light in the blindfold. The core sensing elements of the device are two large area photodiodes positioned directly inside the mask cavity in front of each eye. The analog front ends follow a conventional photodiode to ADC signal path, where used a transimpedance amplifier and a voltage amplifier, following by a microcontroller. Then it was sent to the computer via USB interface using ASCII protocol, which was monitored by software. Our collaborator, Bernat Alvet, contributed to the design of and development of process, and this is the result. At the top, we can observe the system measurements for both left and right eyes. In this way, we presented a solid answer against the inadequate blindfold argument. We conclude that there is light in the blindfold, and it's lower than 2 millilux. Well, 2 millilux are 0.002 lux. Below 100 lux, error scores on color vision test increase. a minimum illumination level of over 5 lux is required for accurate color perception. Below 0.05 lux, vision becomes scotopic, making it difficult to distinguish shapes and eliminating color perception. The second argument is clever hands phenomenon. Facilitators or parents who know the correct answers may have unknowingly provided cues through body language, verb and tone, or subtle reinforcement. A horse named Hans drew worldwide attention in Berlin as the first and most famous speaking and thinking animal. Hans solved calculation by tapping numbers or letters with his hoof in order to answer questions. Later on, it turned out that the horse was able to give the correct answer by reading the microscopic signal in the face of the questioning person. The clever hands phenomenon can be avoided by isolating the children in a controlled environment, such as a laboratory. Well, and the last argument, argument 3, is the lack of research argument. Extraocular vision, or non-ocular light sensing, is a scientifically recognized biological phenomenon, but it's limited to invertebrates. For instance, octopus suckers may have the ability to sense light in specific areas of the arms. Consequently, when searching for extraocular vision applied to human sight in a standard scientific database like Science or Nature Cells, no relevant scientific findings were found. Inferring that the lack of research proves one phenomenon cannot exist may be a naive acceptance. In science, we need methods and experiments. We need proofs. Next, I will share our small contribution. Before that, I want to emphasize that I can't convince anyone about extraocular vision phenomena. And this is not our goal. In the end, it is only science and data that can provide convincing answers. The goal of this pilot experiment was to determine whether investing resources in extraocular vision research is worthwhile. In our pilot experiment, we studied the effects of short-term visual deprivation on blindfolded healthy Spanish children trained to see in low light conditions evaluated using an EEG technique. As children exhibit the potential to develop multiple forms of extraocular vision, the inclusion criteria for participants in our study were as follows. Evidence of extraocular vision occurring independently of tactile input. Demonstrated ability to perceive stimuli through any blindfold following an habituation period. Capacity to detect a visual stimulus aligned with the visual axis at the level of the eyes. Summarize of methodology and results, the study participants were healthy children between the age 10 or 17. This is the demographic data. And we used a within-subject experiment design, 2 conditions under study, a standard vision condition without a mask, blindfolded visual condition, blindfolded with a mask. And it was the task. We used participants perform a task color in 2 blocks of 50 trials in each condition. 5 different color cards were defined from the rainbow color X. We collected 1,270 randomized trials in the standard vision condition and blindfolded vision conditions. And we used an external button to respond, to capture the participants' reaction times, and a microphone to record the answer. The test look like this. If we calculate the probability in a color task composed of 5 cards with 5 different colors and 100 trials, we expect a 24% chance of correct answer in the best case. The behavioral results were as follows. The table 1 shows the percentage of correct trials for all types of stimuli for the two conditions, both at the individual and group levels. On average, participants committed fewer errors in the standard vision than in the blindfolded visual condition. Notice that the accuracy is 73% higher than expected in the color tags for 100 trials in the best case scenario. Table 2 shows the reaction times. The participant responded faster in the standard vision condition than in blindfolded condition. The average difference in reaction times between conditions was around 165 milliseconds. After the behavioral analysis, we processed the EEG signals. The stimulus-locked event-related potentials, ERPs, were estimated. EEG data were bandpass filtered using butterboard filter. EEG data were approached and diminished. Then the EEG signal was segmented. All epochs were baseline corrected. The figure 1, this figure, represents the grand average ERP over Pareto occipital electrodes. Top graph, grand average ERP in standard vision, gray, and the blindfolded vision, red conditions. Shaded areas denote the standard error of the mean, and dotted lines represent the zero amplitude, and solid lines indicate the stimulus onset, and color dashed line denote average mean reaction times for standard vision and blindfolded vision. And bottom graph, difference between grand average ERP between conditions. The solid dark line at the bottom of the x-axis denote the significant cluster of p-values from a paired t-test comparing standard vision and blindfolded vision ERPs over time. P-values were corrected for multiple comparisons via the cluster-based permutation test. And then we did the flanker task. The flanker task assists the attention and conflict resolution by presenting a central target letter flanked by congruent or incongruent distractors. Participants must identify the central letter as quickly and accurately as possible. Reaction times are typically longer and accuracy is lower in incongruent trials, indicating cognitive interference. This paradigm shows executive control and is widely used in cognitive neuroscience, and the results were as follows. The table 3 contains the percentage of correct trials and the individual at group levels. Overall, participants responded 99% of congruent and 98% of incongruent trials in a standard visual condition, and 97% of congruent and 95% of incongruent trials in blindfolded condition. Regarding congruent trials, there is a difference of 2% between standard vision versus blindfolded vision conditions. As one would expect it in a typical flanker task, participants responded faster to congruent versus incongruent stimuli in the standard vision condition. In the congruent trials, 3 participants responded faster in the blindfolded visual condition rather than the standard vision condition. Whereas in the incongruent trials, 2 participants were faster in blindfolded visual condition than in the standard visual condition. This is ERP analysis. Top graph, run average ERP of blindfolded visual in red trials for incongruent conditions. Color dashed lines denote average mean reaction times for congruent and incongruent conditions. And bottom graph is the difference between run average ERP between conditions. The solid dark dots at the bottom of the x-axis denote the significant cluster of p-values from a pair t-test comparing ERP over time. Key findings. With less than 2 millilux in the blindfold, the primary visual cortex was aware of the visual stimuli even when the information wasn't present in the retina. A time frequency analysis revealed increased alpha activity in standard visual condition and decreased alpha and beta activities in blindfolded condition, indicating different cognitive strategies of neural dynamics. In color tasks, the accuracy was 97%, which is 73% higher than expected in a color task for 100 trial in the best case scenario. A standard visual condition presented larger amplitudes than blindfolded visual, suggesting enhanced early and late visual processing. Lower processing times were observed in a standard visual condition compared to blindfolded visual condition, and ERPs showed differences in early sensory processes in 1 and high-order cognitive processing with 2. And flanker task, the late neural activity reflects cognitive processes associated with conflict detection or resolution during extraocular vision phenomena. The absence of visual input in extraocular vision alters the early processing of congruent stimuli, possibly requiring additional cognitive effort or alternative sensor modalities to compensate for the lack of retinal information. And future directions and limitations, the tendency to place excessive confidence in finding from a small sample is a common bias that leads to generalization, misinterpretation, and erroneous conclusion. We need to increase the current sample size, of course. The goal of this pilot experiment was to determine whether investing resources in extraocular vision research is worthwhile. Based on the results, we have decided to continue our research. In the current experiment, we are using EEG, source localization, FNIRS, and thermographic imaging. And it's the best part for me. During a casual interviews with trainers and participants after the study, we detected that the mindset of the children may be more open than conventional views about the visual perception. Let me provide an example. Can you see the things on your left? No, I can't. I don't have eyes where my ears are. But your eyes are blindfolded. You aren't seeing with them. Yes, but I am seeing through the holes in my eyes. Then try to use the hole of your ears as if they were the holes of your eyes. You are right. No, I can see them. Following this experience, we find ourselves asking, is there a link between our mindset and perception? Can our thoughts influence visual cognitive skill? Can you feel the potential of this possibility? We can. And we are driven to explore them in greater depth. Before closing, I'd like to share a quote that helped me return to the essence of researching consciousness. We aren't a brain researching consciousness. We are consciousness researching itself.
We have time for a couple of quick questions. I'll be actually I think for accuracy, David requested if I could translate his answers in Spanish. So the questions will be in English.
Please,
I'll be
it will be
translating.
more accurate.
So we have some people over here. So David will reply in Spanish and I'll translate to English, okay?
Does it work with the other senses too?
Sí.
Yes.
Have you experimented it?
¿Qué preguntó? Yeah.
The question.
So these experiments were visual experiments.
Visual, yeah.
But have you experimented also other senses? For example, the sound or the feeling or other senses?
Todavía no. Esto fue un experimento para ver si como laboratorio tenía sentido seguir invirtiendo recursos en estudiar este fenómeno.
Okay, sorry, he didn't understand the question at first. The answer is not yet. The reason why we did this experiment was to figure out if it made sense to continue investing resources, because at first sight, this looked incredible from a scientific perspective. So we did this study to decide whether we wanted to continue moving forward.
Tenemos diversas hipótesis y una de ellas podría ser terminar estudiando el fenómeno de la sinestesia, que nos llevaría realmente a estudiar otros sentidos perceptivos en este contexto.
We're now trying to explain why this works. We have different hypotheses. One of them has to do with synesthesia, and that could open up new avenues for investigation regarding other senses. Okay, well, a lot of people. Tough job choosing.
Thank you. I was curious as to what the children actually see and how they see it. Do they see it in their mind's eye, or do they just intuit it and know, perhaps like a psychic phenomenon?
¿Entendiste? Más o menos. Sí. It's better for me.
So this question has actually been asked multiple times to our kids, and there are multiple answers. Some of them say they can see with their blindfolds on exactly as they see without it. Some of them say that they see through their third eye. Some of them see it comes to them as a thought. So there are multiple answers.
Thank you.
Okay, some more?
Come with me.
I'm glad I'm not dispatching the mic.
Right. So, David, when we think about the parapsychology database, extrasensorial perception, usually there's some level of noise in the input of the participant. If you think about remote viewing, for example, you don't expect the viewer to describe precisely the target, right? So here what you're showing is the 100% accuracy. Also in the demonstration, what is your understanding about this lack of noise in what you're seeing?
It's an amazing question. No lo sé. Y en primer lugar,
in case you didn't understand.
Yeah. Y en primer lugar es porque tengo la mala costumbre de responder a las preguntas investigando, porque me doy cuenta de que mi mente está tan sumamente sesgada de que no importa lo que yo piense en el laboratorio. Lo que realmente importa es lo que los datos tienen que decir.
Okay. I have the bad habit of answering questions researching, because my mind is so biased that it doesn't matter what I think in the lab, it's the data that I trust.
Así que tu pregunta me inspira muchísimo para seguir lanzando hipótesis de investigación que nos permitan abrirnos a nuevas posibilidades.
So your question is very inspiring to keep moving in this direction of opening new avenues of research to open a new universe of possibilities. Okay, here.
So my question is about, is this training available to adults, or our brain are already too rigid to do that. And there was a recent short film by Wes Anderson, A Wonderful Story of Henry Sugar, where the guy was very rich, then he learned to do the extraocular vision in order to get rich by reading the cards. And when he learned that by extensive meditation, he decided that he doesn't really need the money, and he did it for a little bit and donated all the money to, I think, children's orphanage or something like that. So, but the question remains about adult brain being available for that type of training.
So yes, we also get this question very often. So the answer is that if you think back to the time when you were kids, do you remember what your mind was like? It was totally pure, unbiased, clear, right? As we grew older, we collected a lot of impressions, and that slightly biased our perception. So with kids, they are very close to nature, and with a few hours of exercises, they are able to train their mind to tune into these frequencies of intuition. So that's not to say that the adults cannot do this, they can, but it probably takes them a longer time. And for example, these amazing abilities like seeing blindfold, I've been training the kids for the past 8 years, and I still can't do it.
So we have time for one just final question, so you choose. Okay, this guy is the lucky one.
Related to previous gentleman asking about the difference between remote viewing, which usually blur. So one experiment can be suggested to think about it. Test the fidelity of your perception to the actual through space and through time. See what's the distance and other variable control, right? Fidelity versus space and time.
You're suggesting an avenue for research, right?
Voy a perder el poco pelo que me queda tratando de responder a la pregunta.
He's going to lose the little hair that he has left.
It's an amazing question, and maybe it will be the next step.
Oh, just a comment and that's it.
I just want, first of all, to thank you very much. And I think it's so important to change, because I believe half of the people still didn't believe that this is impossible, even people coming to consciousness. And this has opened the mind of people here, but also very important to bring to the education, because the existing science is blind to all this. It's very important to change the science to understand that the physical science is limited to this. Thank you very much.
Thank you for the presentation.
Thank you. I'm afraid we're going to have to leave the Q&A session here, because we don't want to monopolize this session. And we'll have plenty of opportunities to talk with David and the people from Art of Living, and even with the kids during the break. But now I would like to call Laxmidhar Behera. He's director of IIT Mandi, and he's going to present a different approach to the research of this kind of phenomenon. Also very valuable and complementary approach. So I'm not going to make much of a spoiler here. I'll just leave you with Laxmidhar.
Thank you.
Thank you very much for giving us this opportunity. I represent IIT Mandi, and specifically the group which is working in the consciousness studies. The center name is Indian Knowledge System and Mental Health Application. IXMA. And we have around 50 researchers working on different domains. So I will speak what David presented, some studies on that, but I would approach perception from a perspective inspired by Indian knowledge system. So I would start with what is consciousness? All of you know this. It's existing. Like David concluded his talk saying, it is the consciousness by which we study consciousness. So I think that's a very good way to end the talk. And this is immutable, immovable, indestructible, unburnt, uncut, unweighed. These are all different properties given in Bhagavad Gita, 2nd chapter. And the nature of consciousness is, it is freed from any kind of ignorance. It's full of joy and knowledge. It has no property that we can ascribe from our physical experience. So obviously, within the empiric domain, it is very tough to study this. But consciousness, we are. This body without consciousness won't exist. So the philosophers in Eastern tradition, they looked at everything from the conscious perspective. So consciousness footprint is there in every aspect of our physical existence. I'll give you, this is a robot. This is the robot from my lab at IIT Kanpur. It participated in Amazon Robotics Challenge in Leipzig in 2016. So if you look at this robot, this was given a list of 10 items to pick up from this rack. So this list, it has to study and look at every box in the rack and find out and put it in the delivery package. So and this kind of work is going on all around the world. With the advent of, I am a professor in AI and robotics, this kind of work I do. But unfortunately, people think this robot is conscious. And I just want to let you know how we make such robot look like human. I'll give you, it may not impress on your, many of you may not be able to appreciate what I will tell, but just listen what is happening. For example, when you make a robot to do certain things, it has to follow a stable behavior. So it is the researcher, he constrains the robot's functionality within an energy function, right? So it should not do things this way or that way, but this way. So that energy function is something like this. Robot doesn't know this energy function. It is the researcher who is designing this robot to behave like a human. He conceives this idea of an energy function. And then this energy function, when you associate this robot with the energy function, you would like this energy function should not go unbounded. This energy function should decay. So time derivative of that energy function, you have to find out, and you get certain messy equation that robot doesn't perceive. And then, for example, this is my PhD student in Indrajano for Indonesia, and he came up with this formula to my office and said, I can't proceed. And then, because there are two terms, P dot and D dot, that has to be figured out. So we sat together and with half an hour of exercise, we got these two messy equations, and this has to be replaced here, and then this v dot has to be ensured to be negative definite. And then robot works. For example, so you see here, the robot follows a pink ball while maintaining a fixed distance between the pink ball and the end effector. So what I'm trying to tell you is that these equations, what you see here, they are conscious construct of the researcher. And this conscious construct of the researcher is embedded into the onboard computer of the robot. And then robot behaves as if it is behaving like a human being. So robot is not conscious intrinsically, but it is my conscious projection that makes the robot to behave as if it is conscious. I just wanted to make a little awareness there, because many people think AI is conscious, robot is conscious. No, consciousness is something that we cannot just hit it there. Because I, first of all, don't understand if I'm conscious. And to say that robot is conscious is something beyond comprehension. So now I will give you a little background how we have approached this problem from Indian knowledge perspective. So if you look at this body, human body or any biological organism, including plant, this body has three things in it. One is pure conscious energy that is not destructible. And then there is mental energy. And third is the physical body. And these three things are so juxtaposed. And of course, there is a process how these three energy coexist. I'm not going to go to the philosophical level on that. But this is how three energies are entangled. And as an internal observer, sometime I am aware of my physical body, sometime I am aware of my mental status, and sometime I'm aware of my very existence as a conscious being. So these are entangled so well, and how I am trying to concentrate on which aspect, that makes me to understand who am I. This I will skip, because if I speak this will take some time. But here, a physicalist view is that you see that all our actions are based on perceptual space, right? And this perceptual space, according to physicalism, it is the emergence of physical space. But IKS view is just opposite. Perceptual space gives rise to physical space. Like, for example, this building first came in the perceptual space of the architect who designed. And then it has manifested, right? You want to manifest a garden, that garden first comes into your perceptual space, and then it descends into the physical space. So that is what I wanted to speak. So now, this will be a little mathematical, but it's very important, because when we speak something, it has to be scientifically grounded. So can perceptual dynamics be non-local? What is local phenomenon? Local phenomenon means there is a neighborhood. For example, heat flow, right? Heat flows from something at a higher temperature to lower temperature, and it doesn't go like that. There is neighborhood, 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 and slowly heat percolates. So this is called local phenomena, or opinion formation you put a smell here, how it spreads throughout the hall. These are all, there is a local neighborhood concept. Whereas non-local phenomena, what is non-local? I'll give you some example. Quantum entanglement, right? So these are okay, so yeah, so you can see here. So this is one electron, the other electron, they're entangled. And let's say the entangled state is spin off, spin down, and spin down, spin up, let's say. So once you have entangled them, then if you put them light years apart, you make a measurement at one level, without measuring, you can know what is there in the entangled electron. So this is one aspect of non-local phenomena that is here, at least in this case, it is not constrained by the space-time constraint, right? It is beyond space-time constraint. I don't know whether Mr. Martin is here. He works in this remote viewing. He came to IIT Mandi and did a session, multiple session with our faculty members, and he could make our faculty members draw a figure without letting them know what this figure is, right? And this was done, in the United States, the Defense Department. This was then. So the idea here is, if you look at this as a science, so consciousness may operate through non-local means, accessing information beyond space-time constraint. So basically, the physical idea of space-time that sometimes gets violated. Synchronicity, this is another thing that I got it. Carl Jung and Pauli, together, they actually worked on synchronicity. What is synchronicity? For example, you are thinking intensely about your very close friend and suddenly his call comes. How do you understand this kind of phenomena? And there are many such things that happens in our life. So how do you explain that? So Carl Jung and Pauli, that together they worked on this, and I don't know whether Praveen Kumar is here or not. He discussed with me to work on this problem almost 2 years back. So non-locality, we have evidence, right, in our day-to-day experience. These are experimental evidences. We don't know exactly how do they work, and because we don't know how do they work, we try to explain them in a non-local way. I'll just give you an example. Suppose I'm walking and I saw a mango tree, ripened mango, and I'm holding a stone on my hand and throwing it and making the mango drop so that I can eat it. So if you look at a classical science, it can only start from the point of release from my hand. What momentum has been assigned to this stone, and that follows a projectile and hits the mango. But there are more things going on. You watched the mango, you looked at it, you developed a desire to eat it. There is an intentionality, and then that processing has made you to hold a stone and you release the momentum that you don't know, but you estimated what momentum should be imparted to that stone, and the mango dropped. So even if we want to make our science richer, we need to bring the ideas of consciousness into the scientific domain and give it a complete shape. So I will, Jyotish sir is here. He's a postdoctoral researcher at IIT Mandi. So he is working on this problem. The problem is, you can see these are all flocks. You have seen flocks of bird, flocks of fish, flocks of insects. So how do they make flocks? Right? Nobody is telling them exactly where his neighbor is. They are not using GPS, certainly. Simply based on perceptual vision or perceptual framework, they take the decision, and based on that decision, they make a flock. So I will just present how we have tackled this problem. So what is non-locality here? Think of the agent is A1, or this is a bird, and it has neighborhood. That neighborhood has neighborhood, and so forth. Right? So non-locality is, I'm not looking at my neighborhood, but I'm looking at far neighborhood. Right? So that is the idea of non-locality here. So when I want to be in a flock, I want to look at a neighborhood and which is not local. So, and what is this neighborhood? Imagine in a distant neighborhood, I'm seeing two of my suppose I'm a bird, I'm seeing two birds flocking, or they're flying there. So what is my status would be when I look at those two birds? I can think that 0, 0 means I do not want to follow them. Okay? Some reason. Or I want to follow one of them, either first bird or second bird. So 0, 1, 1, 0. Or I may say, now I will follow those two birds because they are in my flock. So this is its own decision making. Similarly, if you can go to the three neighborhood concept, so you can say, I will follow none of them, I'll follow one of them, I'll follow two of them, or I'll follow three of them. Right? All possibilities there. This is a superposition of all of them. So we are creating a quantum the framework, a quantum dynamical framework to explain how this happens. Now, once we make a formulation of this, we can also create entanglement. Right? It's not here. Entanglement means I will follow either all of them or none of them. This is entangled state. Because those who have some idea about quantum mechanics, you will understand. Or I'll follow either one of them, thus entangled, 0, 1, 1, 0. They are not product state. So this is, so all these possibilities are there, right? And once those possibilities are there, so this is happening at the perceptual level, and certainly certain processing is happening, that how I am going to take a decision. So that decision making happens based on an operator. So I have a superposed state, or I am in a superposed state, and on that superposed state, I am applying my decision making which is a quantum operator. And this is a quantum operator, you can see. OIK is a quantum operator. And you may ask this question, how do you find? It's based on, again, the intuition comes always. How, when we work on certain problem, if there is no intuition, probably never there will be any research, right? And once you do this, these are all entangled state. And this is the dynamics. And where, of course, I have not shown the quantum dynamics. It is once you make a quantum dynamical equation and take the average of that quantum operator, you come to a classical equation. And this classical equation for a two-neighbor case will come, if you do some math, you will see this is the expression. And this turns out to be a Vizek model, and this is known already in flocking community. This is a very popular model that ensures flocking in a group, right? So we showed you that how we started with a framework from perceptual level, and that perceptual level framework through quantum dynamical evolution can come to a physical equation or classical, simple differential equation. You can see now those these kind of things makes the system, which was in the beginning highly randomly oriented, has a orientation of having a flock. And so there are some studies we did. The order parameter quantifies the average alignment of agent. For example, there is an order parameter, and that order parameter has been defined there in terms of average of the momentum. And you see, order parameter is naturally, ideally should be 1. If order parameter 1, then all the members of the flock are together, right? So that is 1. And this is a classical thing, and we have found what is the counterpart in terms of non-classical or quantum framework. And we have an equation, and we are also seeing that this order parameter is becoming stagnant, a very definitive value, saying that all the flocks, all the members in a flock are in the same orientation. So this is the first mathematical framework by which we try to explain how a perceptual framework can lead to a physical action. Like, imagine this, throwing of the mango, perceptual framework, and giving rise to exact momentum that has to be imparted to the stone. So now, what is the time I have now? 10 minutes, okay. So I will go this one very fast. This was the work that was done before the work that I presented. We first solved this problem classically. So that was quantum mechanically. Here it is classically. Classically, again, the same concept that I do not follow my immediate neighbor, but I follow distant neighbor. And using the Ricci curvature, which was there in special relativity theory, and what is a Ricci curvature? That is, you connect all these agents who are there in the flock, you get a network, and then based on that, you compute this Ricci curvature, the value at every node, and if you find that is negative, then you follow like now flock happens because of following the most curved ascent and ascent with most minimum Ricci curvature. So when we do this, again, we find the flocking happens, right? I will now go to the one that was presented in my previous talk by David. So we run a Gurukul in Vrindavan in India, where 30 students have been trained in this folded non-vision visual experiment, right? And so this, because they have already shown the demonstration, I will not go to the video. So I will just show you that they showed how through EEG they studied it. But we used both EEG and a megahertz signal, right? We had Hide is here. He gave us a machine. It has a single probe, but we are now making multi-probe megahertz system to study this. But in single probe, what we saw, similar experiment. You can see the experimental setup, non-vision visual perception experiment. So there were 30 fully randomized stimuli, 10 each from words, numbers, and image category. So you can see image and then number and word. So, and then they were given after being blindfolded, and we received their stimulus. And we looked at what is happening through EEG and what is happening through the megahertz signal that we, 6 to 26 megahertz signal. So it is known already that the visual, when there is a visual stimuli is there, the EEG activity is prominent between 22 to 45 Hz. This is already known thing. And so if you look at that, what happened is that we are collecting EEG signal of a person. His response time may be 2 seconds, 10 seconds, 12 seconds, and you divide them by 1 second epoch, right? And now you compute the band power per epoch and average it across the epochs and draw a scalp EEG plot. So you can see when I am watching or looking at things without the being blindfolded, there is very little action as far as neuronal activity is concerned. There are very little. Whereas you can see blindfolded, there the activities are more. That's easy. And you can see we found p-values and for words, numbers, and images, and you can see they are statistically significant because it should be less than 0.05 to become statistically significant. So you can see parietal and central, they are not statistically significant, but these frontal, temporal, and occipital, they're statistically significant. Whereas when we did, this is Anirvan has shown, you will see triplet. So you can see there a triplet, and there are 3 areas. The triplet means this is this and the other one. So you can see here when we only using one probe, and that probe was placed here because most of the time the students or the children, they said they are seeing here. So we placed the probe there, and based on that, you can see the p-value is highly significant. 4, 10 to the power minus 13, minus 6, minus 7. So obviously, megahertz signal is giving us much better idea about the perceptual ability of these people. But we still don't know how this is happening. And that requires a long-term research. So you can see EEG showed only moderate p-value, whereas high-frequency probe revealed much stronger and clearer difference, high value of p. High-frequency electromagnetic fluctuations may capture subtle perceptual and cognitive dynamics not visible in scalp EEG. Suggests future potential for high-frequency probes as powerful tools to study subtle brain activity beyond EEG limit. So again, this high-frequency signal, where they are there, because all of us, we know brain is simply a 100 Hz maximum, 100 Hz machine. So from where this high-frequency signal is coming? So this is again a bigger research that needs to be done. I will end this one with another non-local phenomena that we saw while trying to understand what is the biomarker of consciousness using anesthesia. So first we did for plant, then we did for C. elegans. So when we gave this anesthesia to both the plant and C. elegans, what we found that normally there is an idea that when you give the anesthesia, consciousness is blocked to the neural circuitry. Similar something is there. But we found out when you give the anesthesia, within the cell, literally all organelles except the nucleus are destroyed or they are decapacitated. They are flushed out of the cell because dead thing has to be flushed. And we also found out, you can see there the only nucleus, within the nucleus there are chromatins, they are strands, small strands, and there are many of them, they are there, and they come because it is in a stressful situation. When you give the anesthesia, it is creating stress in the system, in the cellular system. And then these chromatins, they are going and staying along the periphery of the nucleus. So we notice this, and this is a detailed thing, what is happening if you put 1 to 2 hours, 4 to 5 hours, until there is cell death. We found out if the nucleus, they die, and their percentage goes below 40%, then the organism dies. This is details is there. This is, you can see about C. elegans, similar result. So there is no distinction between plant and C. elegans as far as anesthetic study is there. But this is all details, I didn't want to present this, but I wanted to show you how can we study this using non-local phenomena that we talked about. That means this non-local phenomena we can see within the biological organism. So for example, the last one you see, these are the chromatins, random chromatins, arranged or they are there randomly within the nucleus. And so you see here, this is the equation. That equation takes, there is a non-local force and there is a local force. And based on that, you can see how these random, these chromatins, they come and they come to the periphery. And this is for single, yeah, I'm done, sorry. So you can see here now how at the multiple nucleus level also, this is being done. Again, the non-locality we were talking about. I will end this. This is, I will skip. This is, I will skip. This is our Indian knowledge system and mental health application. We do a lot of research on this. So conclusion, perceptual space being very subtle cannot possibly be explored by classical methods. Non-locality is one of the strong scientific ideas by which we can study subtle and gross interaction. So study of gross and subtle interaction will lead to the development of psychological trait of biological organism. The conscious biomarkers that will be valuable in therapeutic applications can be developed through such gross and subtle interaction. Ultimate goal is to show that physical space is the emergence of perceptual space, an idea from Indian knowledge system. Thank you very much.
Okay. We're running out of time, but we're going to take a couple of questions. So,
thank you very much for the talk. So, I think your initial explanation as how the physical space first comes into our mind and then it happens into reality. So, you're not denying the physical space as real eventually?
Yeah, physical space is also real.
Okay, thank you.
Yeah. Yeah.
Thank you, sir, for a brilliant presentation. I just wanted to have one doubt, which I with this Bell's theorem of inequality, which was experimentally proven in, I think, 2022, it kind of totally annihilated the concept of unknown variables as proposed by Dr. Albert Einstein. Do you think there's a possibility that just the Bell's inequality theorem, having disproved Einstein's theory of, unknown variables, is it really, could there be a remote possibility that these unknown variables might still be there and which we are not aware of, which could possibly explain entanglement and non-locality?
One thing is very sure, that very little has been understood about the experiential world. Very little has been understood. So, by bringing the dimension of this subtle and gross interaction, the possibility of understanding the universe is going to surely change how we look at that universe, right? So, for example, you talked about this Einstein's theory of relativity. What Einstein's theory of general relativity did, actually we started with the Newtonian laws of universal gravitation, how two big bodies are attracting each other, right? And they are floating in the space. But Einstein's special theory of relativity, because it's kind of a non-local thing, right? How two bodies are getting connected or they're getting attracted to each other, nobody knows, right? Whereas he did the space-time continuum and explained how it is not a non-local phenomena, it's a local phenomena. So what I'm trying to explain here is that the idea of matter, the way we are being taught, that idea has to change. And then our idea of the experiential world also will change. Thank you.
Okay. Thank you very much, Professor Behera. I think everybody is, the ones that were starving the most already left. So But I guess everybody's hungry, so we're going to have the lunch break. I wanted to make a quick announcement, though. Some people are asking if you have access to the live stream. In fact, you don't, but we just thought we should give you access to the live stream. So what we're going to do, once the conference is over, we'll create a free code and we'll email it to everyone so you can watch. Until the end of the month, you can review all the talks that happen in the plenary, which are in this room, which are the only ones that were actually recorded and live streamed. Okay, so you will be receiving that. And other than that, I just want to say that I'm devastated today because after seeing that girl with the blindfold could play video games faster and better than me without, I don't know what I'm going to do with my life. So I'm going to go get something to eat. Thank you very much. I'll see you around.